Good evening and welcome to Physics for Sleep. Tonight we embark on an intellectual journey exploring the profound question of what the universe is expanding into and how space itself stretches and grows. Before we gently immerse ourselves in the vastness of cosmic expansion, I would like to know where you are at this moment. Perhaps you are comfortably settled on a window seat, watching the distant city lights blur into soft streaks. Or maybe you are curled up on a soft rug, a gentle rain tapping against the window pane. If these deep reflections help you relax and organize your thoughts before sleep, please support the channel with a like and subscribe so others can find their way here too. Now, just breathe, allow your eyes to grow heavy, and let's begin. The question of what the universe is expanding into is one that often arises, conjuring images of a grand cosmic bubble stretching outward into some larger, empty void. Yet the reality, as revealed by the profound insights of modern cosmology, is far more subtle and, in its own way, even more astonishing. When we speak of the universe expanding, we are not talking about galaxies rushing through a pre-existing static space, as if they were shrapnel from an explosion. Instead, it is space itself that is expanding, growing and stretching, carrying the galaxies along with it. This distinction is crucial, for it means there is no edge to this expansion and no outside for the universe to fill. The universe, in this cosmological sense, is everything, and its expansion is the continuous creation of more space within itself. To truly grasp this, let us return to the familiar analogy of the surface of a balloon being inflated. Imagine tiny celestial bodies, like galaxies, drawn upon its two-dimensional surface. As the balloon expands, every drawn galaxy moves away from every other drawn galaxy. There is no central point on the surface from which they are all fleeing. Each galaxy observes all others receding from it, a uniform exodus driven not by their own motion across the surface, but by the stretching of the rubber itself. Now, this analogy is imperfect, as it represents a two-dimensional surface expanding into a third dimension. Our universe, however, is thought to be three-dimensional space, expanding into nothing external. It is the very fabric of our three-dimensional space that is stretching, not through some higher dimension, but intrinsically from within. This means that new space is simply coming into existence between gravitationally unbound objects, gently pushing them further apart. This profound understanding began to solidify in the 1920s, largely through the groundbreaking work of astronomers like Edwin Hubble. Observing distant galaxies, Hubble discovered a remarkable pattern. The farther away a galaxy was, the faster it appeared to recede from us. This relationship, now known as Hubble's law, was a pivotal moment in cosmology. The primary evidence for this recession comes from the phenomenon of redshift. As light from these distant celestial islands travels across the vast cosmic distances, the space it traverses expands. This stretching of space literally elongates the light waves themselves, increasing their wavelength and shifting them towards the red end of the electromagnetic spectrum, much like a siren's pitch drops as it moves away. This is not merely a Doppler effect caused by galaxies flying through space, but rather a direct consequence of the stretching of space itself. Further confirmation of this pervasive expansion comes from the cosmic microwave background radiation, the faint echo of the Big Bang, which permeates all of space and exhibits a uniform cooling over time, consistent with a universe that is steadily growing larger. One might then reasonably wonder, if everything is moving away from everything else, does that imply a center to this expansion, a point from which everything originated? Here again, our everyday intuition, honed by experiences within a static framework, can be profoundly misleading. The expansion of the universe has no identifiable center. Just as every point on the surface of an inflating balloon moves away from every other point without any single point being the center of the expansion, so too does every region of our universe experience this stretching of space. No matter where an observer is situated in the cosmos, they would witness the same universal outward flow, with distant galaxies receding from their vantage point in every direction. This concept is fundamental to the cosmological principle, which posits that the universe is homogeneous and isotropic on large scales, meaning it looks roughly the same everywhere and in every direction. Such a universe, though potentially finite, has no edges and no privileged center, much like the surface of the Earth is finite but boundless. This dynamic view of space is deeply rooted in Albert Einstein's revolutionary theory of general relativity, which was published in 1915. Einstein's equations revealed that space and time are not separate, static entities, but are interwoven into a single, flexible fabric called space-time. This fabric is not a passive stage where cosmic events unfold. Rather, it is an active participant, capable of being warped and curved by the presence of mass and energy. The expansion of the universe is precisely this, a change in the geometry of space-time itself. It is not an event happening within space, but rather the evolution of space itself. It is the very structure of the cosmos that is changing, growing, weaving new distances between us and the most remote celestial islands. This means that when we look out into the night sky, we are not just observing objects in space, but witnessing the profound evolution of space itself, a silent, ceaseless unfolding that reshapes reality on the grandest scales. What then is driving this relentless expansion? For a long time, scientists assumed that the gravitational pull of all the matter in the universe would gradually slow down this expansion. However, in the late 1990s, astronomers made a startling discovery. The expansion of the universe is not slowing down, it is accelerating. Something is actively pushing space apart, causing it to stretch faster and faster. This mysterious force, or property of space, has been dubbed dark energy. While its exact nature remains one of the greatest puzzles in modern physics, current cosmological models suggest that dark energy makes up about 68% of the total energy density of the universe. It is a pervasive, repulsive force inherent to space itself, essentially causing more space to generate more dark energy, leading to an ever-increasing rate of expansion. This suggests that the void is not merely inert, but actively participating in the cosmic drama, a subtle yet powerful force shaping the destiny of everything. It is important to remember that this cosmic expansion is a large-scale phenomenon. We do not observe our bodies, our homes, our planet, or even our solar system stretching. This is because local gravitational forces and other fundamental interactions are overwhelmingly stronger than the expansive pull of dark energy on these smaller scales. Our galaxy, the Milky Way, and its immediate neighbors in the local group are gravitationally bound, meaning they are moving towards each other or orbiting a common center, unaffected by the overall expansion of the universe. The expansion only becomes evident when we observe structures that are not gravitationally bound to each other, such as distant galaxy clusters, where the stretching of space between them truly dominates their relative motion. Consider for a moment what this implies for your own existence, nestled within this vast and dynamic cosmos. You are a part of this expanding tapestry, a collection of atoms held together by forces that resist this universal stretching on local scales. While distant galaxies drift apart, your own being remains cohesive, a testament to the strength of the fundamental forces that govern matter. Yet the very space around you, in a subtle and immeasurable way, is also part of this grand unfolding. It is a profound reminder that our understanding of reality is constantly evolving, challenging our most basic assumptions about the nature of existence. What does it mean for our place in the cosmos to be part of something that is not just immense, but actively growing, moment by moment, without a true boundary or an external end? It evokes a sense of deep wonder, a quiet contemplation on the dynamic nature of everything we perceive and our fleeting yet significant presence within it. The universe is not merely expanding, It is an active, living entity, forever reshaping its own boundaries, and in doing so, it continually redefines our perception of its profound and infinite mystery. We have reflected upon the astonishing fact that the universe is not expanding into something, but rather that space itself is stretching, creating new distances between galaxies. This concept, so fundamental to our modern understanding, often challenges our intuitive grasp of reality. We are accustomed to thinking of expansion in terms of objects moving through a pre-existing container. But imagine, if you will, not a container, but the very canvas upon which all is painted, slowly, invisibly growing larger. This growth is a property of the cosmic fabric, the very geometry of space-time, and it means that for every unit of distance, more distance is being added. It is a continuous, gentle unfolding, an intrinsic property of the cosmos that does not require an external void to receive it. The universe in its entirety is the space, and its expansion is merely the increase of its own internal distances, a subtle yet profound act of self-generation that permeates every corner of its vastness. This is not a dramatic outward surge, but a pervasive, quiet stretching that happens everywhere at once, unseen by the casual eye, yet measurable by the most sensitive instruments. One of the deepest questions arising from this expansion concerns the ultimate geometry of our universe. Is it open, closed, or flat? These terms describe the overall curvature of space on the grandest scales, and each carries profound implications for its past, present, and future, as well as for the very nature of its boundlessness. A closed universe, much like the surface of a sphere, would be finite in extent, but boundless, allowing a journey in one direction to eventually return to the starting point. Its destiny, under the influence of gravity, would likely be a big crunch, where expansion reverses and all matter collapses back in on itself. In contrast, an open universe, akin to a saddle shape, would extend infinitely and expand forever, its curvature causing parallel lines to eventually diverge. A flat universe, conceptually like a vast endless plane, also expands indefinitely, though at a decelerating rate, if not for the influence of dark energy. Here, parallel lines would always remain parallel. For decades, cosmologists have meticulously analyzed data to discern which of these geometries best describes our cosmos. The most compelling evidence comes from precise measurements of the cosmic microwave background radiation, the ancient light from the early universe. These observations, particularly those from missions like the Wilkinson Microwave Anisotropy Probe and the Planck satellite, reveal subtle temperature fluctuations in this background radiation. The angular size of these fluctuations acts as a cosmic ruler. If the universe were closed, these hot spots would appear larger than they are. If it were open, they would seem smaller. What we observe points overwhelmingly to a flat geometry. This means that parallel lines, if extended indefinitely, would remain parallel, and the sum of angles in a large triangle would precisely equal 180 degrees, just as in Euclidean geometry. This finding aligns beautifully with the theory of cosmic inflation, a period of extremely rapid expansion just fractions of a second after the Big Bang. Inflationary models naturally predict that the universe should be extraordinarily flat, smoothing out any initial curvature. It is as if a tiny, wrinkled region of space-time was stretched so dramatically that it became virtually flat on observable scales, much like a small bump on a balloon becomes imperceptible when the balloon is fully inflated. This elegant connection between the geometry of the universe and its earliest moments provides a profound anchor for our understanding of cosmic evolution. Yet, even if the universe is spatially infinite, our perception of it is limited. We speak of the observable universe, which is the spherical region of space from which light has had time to reach us since the Big Bang. This is not a boundary of the universe itself, but a boundary of our current observation. Imagine yourself at the center of a vast, ever-expanding sphere of light. Everything within that sphere is what you can potentially see. Beyond it lies the unobservable universe, regions from which light simply has not had enough time to travel to us, even at the incredible speed of light over the 13.8 billion years of cosmic history. This limit defines our cosmic horizon, a boundary of information rather than of physical space. It recedes from us as time progresses and light from ever more distant regions finally arrives. This means that the universe we perceive is a constantly growing sphere, but it is a sphere centered on us, the observer, and every other observer in the cosmos has their own unique observable universe, their own cosmic horizon stretching out around them. This realization can be both humbling and exhilarating. We are confined to our own cosmic window, able to glimpse only a fraction of what might truly exist. Yet, within this observable realm, there is an astounding immensity, a symphony of galaxies and structures that continues to inspire awe. To ponder the unobservable, the vast regions forever beyond our sight, is to acknowledge the profound mystery that still envelops us. It suggests that the true scale of existence might be far grander than our most ambitious measurements or theories can currently capture, reminding us of the endless depths of discovery that lie ahead, or perhaps forever out of reach, a quiet invitation to contemplate the boundless nature of reality itself. It reminds us that even with all our technological marvels, the universe holds secrets that may forever whisper just beyond our grasp, inviting a deep, tranquil contemplation of our place within its grand, expanding story. We have reflected upon the vastness of the observable universe and the profound mystery of the regions beyond our cosmic horizon. This boundary, defined by how far light has traveled to us over 13.8 billion years, reminds us that our perception is inherently limited, a fleeting snapshot of an ever-growing cosmic tapestry. Yet, even within this observable sphere, a deeper, more enigmatic force is at play, one that not only orchestrates the stretching of space, but accelerates its very expansion. This mysterious entity, which we call dark energy, represents perhaps the most profound puzzle in modern cosmology, shaping the ultimate destiny of everything we know. Dark energy is not a form of matter or radiation in the conventional sense. It does not clump together or interact with light. Instead, it appears to be an intrinsic property of space-time itself, a pervasive pressure that gently pushes the cosmos apart, causing the expansion to speed up rather than slow down under the influence of gravity. The discovery of this accelerated expansion in the late 1990s by independent teams of astronomers, including Saul Perlmutter, Adam Rees, and Brian Schmidt, came as a profound shock to the scientific community. They were studying distant supernovae, using them as standard candles to measure cosmic distances and the rate of expansion. The unexpected result was clear. The universe's expansion was not decelerating, as gravity would suggest, but was instead gaining momentum. This accelerating force aligns with a concept first introduced by Albert Einstein into his equations of general relativity: the cosmological constant. Initially, Einstein added this term to allow for a static universe, a notion he later famously called his biggest blunder after Hubble confirmed cosmic expansion. However, the cosmological constant, representing the energy density of empty space, now seems to be the most viable explanation for dark energy. It suggests that the vacuum of space is not truly empty, but possesses an inherent energy that exerts a repulsive gravitational effect. As space expands, more vacuum comes into existence, and thus more dark energy, leading to a self-reinforcing acceleration of the cosmic stretch. It is a subtle, constant hum of energy woven into the very fabric of existence, driving the universe towards an ever more diffuse future. The implications of this relentless acceleration are profound for the long-term fate of the universe. If dark energy continues to dominate, the most widely accepted scenario predicts a heat death of the universe. This is not a sudden, dramatic apocalypse, but a gradual, quiet descent into ultimate cold and emptiness. As space continues to expand and accelerate, galaxies that are not gravitationally bound to our own local group will recede beyond our cosmic horizon at an ever-increasing rate. Their light will become so stretched and faint, so redshifted, that it will eventually fade into an undetectable whisper. Over trillions of years, even the stars within galaxies will exhaust their fuel, collapsing into white dwarfs, neutron stars, and black holes. These remnants will eventually cool and evaporate, leaving behind a cosmos of ever-increasing emptiness, where the distances between any remaining particles become astronomically vast. Imagine a future far beyond human comprehension, where civilizations might gaze out into a night sky that is almost entirely dark, devoid of the luminous galaxies we see today. They would be isolated, trapped within their own gravitationally bound cluster, with no discernible evidence of the grand cosmic tapestry that once connected us all. The universe in their epoch would appear profoundly different, a testament to the ephemeral nature of our current, vibrant cosmic view. This cosmic isolation, though occurring on timescales that render it almost abstract, offers a profound reflection on the fleeting nature of our present cosmic window. We exist in a unique moment, a brief golden age where the universe is rich with observable structure, where light from billions of galaxies still reaches our telescopes. Our consciousness, our very ability to ask these questions about cosmic expansion and its destiny, exists within this precious, temporary epoch. To consider this deep future is to realize that our present view is a gift, a rare opportunity to witness a universe still teeming with light and wonder, before the slow, inexorable stretching of space potentially carries much of its grandeur beyond our reach forever. The cosmic journey we have undertaken, exploring the universe's expansion not into a void, but as the stretching of space itself, and contemplating its distant, quiet end, naturally leads us to reflect upon its dramatic beginning. For it is in the very first moments, just after the Big Bang, that the seeds of this expansion were sown, and the stage was set for the cosmos we inhabit. Our current understanding points to a period of astonishingly rapid growth known as cosmic inflation, a theoretical framework developed to resolve several perplexing questions about the universe's initial conditions. Imagine, if you will, the universe as an infinitesimally small, incredibly dense point, brimming with unfathomable energy. Then, in an instant, a burst of exponential expansion occurred. This was not the gradual stretching we observe today, but a superluminal acceleration where space itself expanded faster than the speed of light. Such a concept, while challenging to visualize, is permitted by the laws of physics, as it is space, not matter moving through space, that undergoes this rapid inflation. This period, lasting for only a tiny fraction of a second, just 100 trillionth of a second, effectively smoothed out any initial irregularities, making the universe remarkably uniform and flat on large scales, much like inflating a tiny crumpled piece of paper to an immense size would make its surface appear perfectly smooth and flat. This elegant solution addresses what cosmologists refer to as the flatness problem and the horizon problem, explaining why distant regions of the universe, too far apart to have ever interacted since the Big Bang, nonetheless exhibit such similar temperatures in the cosmic microwave background. This theory of cosmic inflation, first proposed by Alan Guth in 1980, is more than a clever mathematical trick. It is supported by the subtle patterns observed in the cosmic microwave background. The minute variations in temperature within this ancient radiation, meticulously mapped by instruments like the Planck satellite, are precisely what inflation predicts. Quantum fluctuations in the very early universe, stretched to cosmic scales by the rapid expansion, forming the primordial seeds for the vast structures of galaxies and galaxy clusters we see today. It is a profound thought that the largest structures in the universe, the colossal webs of galaxies stretching across millions of light years, may owe their existence to quantum jitters on the smallest conceivable scales, magnified into cosmic reality. This transformation of quantum uncertainty into cosmic architecture offers a truly humbling perspective on the interconnectedness of all scales of existence. But the theory of inflation holds an even more radical implication for our understanding of cosmic expansion. the possibility of a multiverse. In some inflationary models, the process of inflation might not have ended uniformly everywhere. Instead, it could be an eternal phenomenon, continuing indefinitely in vast regions of a larger meta-universe, while in localized pockets like our own, inflation ceases, giving birth to separate bubble universes. Each of these bubbles would then expand and evolve according to its own initial conditions and fundamental physical laws. Our universe in this grander cosmic landscape would simply be one bubble among an infinite or near infinite ensemble of other universes, each perhaps vastly different from our own, with varying constants, different types of particles, or even entirely distinct dimensions. This concept profoundly shifts our perspective on what the universe is expanding into. It suggests that our universe is not expanding into an external void of nothingness, but rather into a continually inflating metaspace that is simultaneously giving rise to countless other universes. It is as if the cosmic expansion we observe is a local manifestation of a much larger ongoing process of universal generation. This eternal inflation theory implies that the universe, in its broadest sense, is an ever-birthing entity, an endless factory of realities, each unfolding according to its own unique cosmic narrative. Such a vast and intricate tapestry of existence, where our universe is but one thread, invites a deep sense of philosophical contemplation. Are the fundamental laws and constants of our universe merely arbitrary selections from an infinite array of possibilities, fine-tuned by chance for the emergence of life and consciousness? Or is there a deeper principle that favors universes like ours? While these questions remain largely in the realm of theoretical physics and philosophy, the very possibility of a multiverse challenges our anthropocentric view, urging us to consider our place not just within one universe, but within an unimaginably diverse cosmic ensemble. It offers a tranquil yet profound shift in perspective, transforming our sense of isolation into a feeling of belonging within an infinitely grander, perpetually expanding cosmic story, where your conscious awareness is a fleeting, precious glimpse into one tiny yet magnificent corner of reality's boundless unfolding. We have ventured into the realm of the multiverse, where our universe might be but one of countless cosmic bubbles, each with its own laws, all expanding within a grander, eternally inflating metaspace. This profound revelation naturally leads us to a deeper inquiry. What is this space that expands, that stretches and grows? What is its most fundamental nature beneath the familiar three dimensions we perceive, interwoven with time into space-time? Our most successful theories of the cosmos, general relativity and quantum mechanics, describe reality with breathtaking precision, yet they speak in different languages, particularly when it comes to the very fabric of existence at its most extreme scales. General relativity paints space-time as a smooth, continuous, and dynamic sheet, bending and flowing under the influence of matter and energy. Quantum mechanics, on the other hand, reveals a universe built from discrete, quantized packets of energy and information. When we attempt to merge these two pillars of physics into a single, unified theory of quantum gravity, the very notion of continuous space-time begins to dissolve, hinting that space itself might not be fundamental, but rather an emergent phenomenon, much like the smooth surface of an ocean emerges from countless individual water molecules. This is the frontier of theoretical physics, where our most cherished assumptions about reality are gently but firmly questioned, pushing the boundaries of our cosmic understanding into realms of profound abstraction. Consider for a moment the profound implications of such a perspective. If space is not an infinitely divisible continuum, but rather composed of discrete, irreducible units, like tiny fundamental grains, then its expansion takes on a profoundly different character. It would not be the stretching of an already smooth canvas, but rather the continuous addition of these elementary spatial atoms. One prominent contender for a theory of quantum gravity is loop quantum gravity, a framework that proposes that space-time is quantized, woven from an intricate network of minuscule loops, far smaller than anything we can currently detect, existing at the Planck scale, which is roughly 10 to the power of minus 35 meters. In this view, space is fundamentally granular, a kind of cosmic weave, not unlike a digital image appearing smooth from a distance, but revealing individual pixels upon closer inspection. The expansion of the universe, then, could be interpreted as the growth of this network, the generation of more fundamental loops, effectively adding new pixels to the cosmic image. This is a subtle, yet powerful reinterpretation of expansion, suggesting that the universe is not pushing into anything external, but rather generating more of its own intrinsic components. It is a quiet, ceaseless act of self-construction, a continuous unfolding of reality from its most elemental constituents. This perspective offers a profound sense of self-sufficiency for the universe, an entity that expands by creating more of its own substance, rather than merely occupying more of an external container. It transforms the perceived emptiness into a dynamic, generative medium, a quiet engine of cosmic creativity. Another theoretical avenue, string theory, offers a different, yet equally radical vision of space-time's origins. In this framework, the fundamental constituents of the universe are not point-like particles, but rather tiny, vibrating one-dimensional strings. The different vibrations of these strings give rise to all the various particles and forces we observe. Crucially, string theory often requires the existence of extra spatial dimensions, typically 10 or 11 in total, which are curled up or compactified into incredibly small scales, rendering them imperceptible to us in our everyday experience. From this perspective, our familiar four-dimensional space-time, including its expansion, could be an emergent phenomenon, a projection or a lower-dimensional manifestation of these higher-dimensional dynamics. The expansion of our three spatial dimensions might then be linked to the unfolding or stretching of these hidden dimensions, or perhaps the way these fundamental strings interact and organize themselves to create the illusion of a continuous, expanding space. This is a concept that echoes the holographic principle we sometimes discuss, where a three-dimensional reality might be encoded on a two-dimensional boundary, implying that our perceived reality is a kind of projection from a deeper, more complex substrate. In this view, the universe isn't expanding into anything in the conventional sense, but rather its dimensionality is being revealed or further manifested from an underlying higher dimensional reality. A silent, elegant dance of fundamental strings, creating the vastness we observe, a symphony of vibrations. The very fabric of our perceived reality, then, could be a mere shadow cast by these unseen, intricate dances. These are not mere philosophical musings, but active areas of scientific research, seeking to bridge the chasm between the very large and the very small to understand the universe at its most foundational level. The immense challenge lies in reconciling the smooth, macroscopic geometry of general relativity, which describes gravity as the curvature of space-time, with the turbulent probabilistic nature of quantum mechanics, which governs particles at the Planck scale. This quest is to uncover the ultimate building blocks of reality and to comprehend precisely how they give rise to the space-time we inhabit and the expansion we measure. These theories push the boundaries of our imagination, suggesting that empty space is anything but empty. It is a vibrant quantum foam, constantly bubbling with virtual particles and latent energy, a dynamic substrate from which everything, including the very expansion itself, arises. This fundamental reevaluation of the vacuum of space is central to understanding what the universe is truly expanding from and how it continues to grow. While still speculative, these theories invite us to consider that the nature of space and time, the very stage upon which our lives unfold, might be far more ephemeral and dynamic than we instinctively believe. Our everyday experience of a solid, unchanging ground beneath our feet and a steady flow of time is a macroscopic approximation, a simplification of a far more intricate and fluctuating quantum reality. The expansion of the universe, when viewed through the lens of quantum gravity, becomes a question not just of scale, but of fundamental ontology. Is the universe expanding by adding more fundamental units of space, or by revealing more of its inherent, higher dimensional structure? This shift in perspective from space as an empty container to space as a dynamic, emergent entity is a cornerstone of our evolving cosmic narrative, prompting us to rethink the very definition of nothingness and its profound active role in the cosmos. And when we consider this, it shifts our perspective on ourselves in a subtle yet profound way. You, listening now, are a complex pattern of particles and fields intricately woven into the fabric of this expanding cosmos. Your very existence, your thoughts, your consciousness are intimately connected to the fundamental laws that govern the universe's origin and its ongoing evolution. If space is emergent, if reality is granular at its core, then your own sense of being, of having a fixed location in an expanding cosmos, is a beautiful, intricate dance of these fundamental constituents. It is a quiet invitation to ponder that perhaps your own personal space, the space of your immediate surroundings, is also, in its own way, a localized manifestation of this grand cosmic stretching. It is a space that feels solid and stable, yet is subtly influenced by the very same expansion that separates galaxies. This deep connection reminds us that we are not passive observers of the universe, but active participants, our very being echoing the grand processes of creation and expansion. This realization can bring a deep sense of calm, an understanding that even in our smallest moments, we are part of something infinitely vast and perpetually unfolding, a silent, graceful dance of existence. We have pondered the profound implications of space itself being an emergent, perhaps even granular phenomenon, rather than an inert, continuous backdrop. This leads us to question the very nature of what we colloquially call empty space, or the vacuum. Our intuition often perceives a void as simply the absence of anything at all. No matter, no light, no energy. Yet, at the most fundamental levels of reality, as described by quantum field theory, such absolute emptiness does not exist. The quantum vacuum is, in fact, a vibrant, restless sea of activity, a dynamic medium constantly teeming with fleeting energy fluctuations. Imagine, if you will, not a serene, still pond, but a deep, dark ocean, where even in its calmest depths, countless bubbles spontaneously form and vanish in a ceaseless dance. These bubbles are analogous to what physicists call virtual particles, pairs of particles and antiparticles that momentarily pop into existence from the vacuum's inherent energy, only to almost immediately annihilate each other, returning their borrowed energy to the quantum field. This phenomenon is not merely theoretical speculation, its effects are measurable. The Casimir effect, for instance, demonstrates that two uncharged parallel metal plates placed extremely close together in a vacuum will experience a tiny attractive force. This force arises because the fluctuating quantum fields between the plates are constrained, allowing fewer virtual particles to exist there compared to the unconstrained space outside, creating an imbalance in vacuum pressure that gently pushes the plates together. This extraordinary observation confirms that even in the deepest void, there is a tangible, energetic presence. This inherent energy of the quantum vacuum is, in essence, the leading candidate for the mysterious dark energy that drives the accelerating expansion of our universe. It suggests that space itself possesses an intrinsic energy density, a pervasive pressure that acts as a form of anti-gravity, gently pushing galaxies further apart. As the universe expands, more space comes into being, and with it, more of this vacuum energy. This creates a self-sustaining cycle. The expansion generates more dark energy, which in turn drives further, faster expansion. It is a cosmic engine powered by the very fabric of nothingness, continuously generating more of itself. This is why the universe is not expanding into something external. It is expanding by creating more of itself from within, powered by the latent energy of the quantum vacuum. The implications of this vacuum energy are not limited to the distant future of the cosmos. They extend back to its very beginning. During the period of cosmic inflation, it is believed that a much more potent form of vacuum energy temporarily dominated the universe, driving its hyper-rapid exponential expansion. This primordial vacuum energy stretched the nascent cosmos to unimaginable scales, smoothing out any initial irregularities and setting the stage for the homogeneous, flat universe we observe today. Even after inflation ended, a residual, much weaker form of this vacuum energy persisted, which we now identify as the dark energy accelerating the universe's current expansion. Thus, the expansion we witness today is a direct descendant of the explosive growth that shaped the very earliest moments of reality. This understanding profoundly reshapes our concept of the cosmic void. It is no longer a passive emptiness waiting to be filled, but an active, energetic medium, a dynamic source of creation and propulsion. The universe's expansion is not a movement through a pre-existing container, but rather the continuous generation of new space, new distances, woven into the fabric of reality by this ceaseless quantum activity. It is a universe that is not merely growing larger, but perpetually renewing and creating its own dimensions from within. Consider this profound dance of creation and expansion, this subtle hum of energy that underlies everything. Your own awareness, your very existence, unfolds within this dynamic, self-generating cosmos. The space around you, seemingly static and familiar, is a part of this grand, ongoing process, a localized manifestation of the universe's intrinsic energy. Peace, a quiet understanding that you are not separate from the vast cosmic unfolding, but intimately connected to its most fundamental rhythms. It invites a contemplative awareness that even in the stillness of your quiet surroundings, the universe is actively expanding, creating more of its wondrous self, and in that silent, majestic process, you're an integral, conscious participant. This cosmic embrace offers a tranquil reassurance, a gentle reminder that your place in the universe is not merely observed, but deeply woven into its very essence, a fleeting yet eternal pattern in the boundless dance of existence. We have just considered the profound implications of the quantum vacuum, a restless sea of energy that may well be the dark energy driving the accelerated expansion of our universe. This invisible force, inherent to space itself, is gently but relentlessly pushing all gravitationally unbound structures further and further apart. This acceleration means something quite remarkable for our cosmic future and indeed for our present perception. It implies the existence of a cosmic event horizon, a boundary far more profound than the mere edge of our observable universe. To truly grasp this concept, let us consider a more detailed distinction. The particle horizon defines the limit of what we can currently observe. It is the maximum distance from which light, emitted since the Big Bang, has had sufficient time to reach us. This horizon is ever expanding, as each passing moment allows light from slightly more distant regions to finally arrive at our telescopes, gradually revealing new celestial wonders. However, the cosmic event horizon presents a different, more absolute kind of limit, one dictated by the accelerating nature of the universe's expansion. Due to dark energy's persistent push, there are galaxies so distant that light emitted from them today, even if traveling at the ultimate speed limit of the cosmos, will never reach us. The space between us and those galaxies is expanding so rapidly and will continue to accelerate its stretching that any light signal attempting to bridge the gap will be forever carried away by the expanding fabric of space-time, unable to ever reach us. This is a concept that challenges our everyday understanding of distance and speed. We are accustomed to thinking of objects moving through space and thus being constrained by the cosmic speed limit of light. Yet here, it is space itself that is expanding. Imagine 2 points on a stretching rubber sheet. The points themselves are not moving on the sheet, but the sheet itself is growing, increasing the distance between them. If the sheet stretches fast enough, two very distant points can effectively recede from each other at a rate greater than the speed of light, not because they are moving through space faster than light, but because new space is being created between them. This is precisely what happens in the universe on cosmological scales. Distant galaxies appear to recede from us at speeds greater than the speed of light, not violating Einstein's theory of special relativity, because it is the expansion of space, not the motion of objects through space, that is responsible. The rate of this cosmic stretching is quantified by the Hubble parameter, often referred to as the Hubble constant, though it is not truly constant but changes over cosmological time. Its value reflects how quickly the universe is expanding at any given moment. Current measurements, primarily from observations of the cosmic microwave background and distant supernovae, suggest a value that indicates the universe is expanding by about 70 kilometers per second for every 3.26 million light-years of distance. However, a fascinating puzzle in modern cosmology, known as the Hubble tension, highlights a discrepancy. Different measurement techniques yield slightly different values for this expansion rate, hinting at either new physics beyond our current models or subtle systematic errors in our observations. This scientific mystery underscores that our understanding of cosmic expansion is still evolving, a testament to the dynamic nature of scientific inquiry. To further clarify how we measure and conceptualize these immense cosmic distances in an expanding universe, cosmologists use two key terms: co-moving distance and proper distance. Co-moving distance essentially refers to a coordinate system that expands along with the universe. Imagine a fixed grid laid across the cosmos. Galaxies might move slightly within their local clusters, but their co-moving coordinates remain relatively stable. Proper distance, on the other hand, is the distance between 2 points as measured by a ruler at a specific moment in cosmic time. As the universe expands, the proper distance between two co-moving points increases. So, while the co-moving distance to a distant galaxy remains constant, its proper distance from us continually grows due to the stretching of space. This means that a galaxy that is now, in terms of proper distance, 46 billion light-years away, was much closer in the past, even though its co-moving coordinates have not changed. The existence of a cosmic event horizon, driven by dark energy, means that there will come a time when all galaxies outside our local group will have receded beyond our ability to ever observe them, even in principle. Their light will simply be unable to overcome the accelerating expansion of the intervening space. This is a profound form of cosmic isolation. Future civilizations, billions of years from now, might gaze upon a night sky almost entirely empty of external galaxies, having no direct knowledge of the vast interconnected cosmos that we currently perceive. Their observable universe would shrink to encompass only their immediate galactic neighborhood. This thought, while perhaps a touch melancholic, also offers a deep, quiet sense of wonder about our fleeting moment in cosmic time. We are privileged to live in an era that paints our skies and fills our telescopes. Our ability to map the cosmos, to study its expansion, and to even conceive of its ultimate fate is a unique gift of our epoch. It is a reminder that our understanding is a temporary window into an eternal process, a brief period of clarity before the cosmic veil of accelerating expansion gradually descends, obscuring the distant tapestry of existence. To contemplate this is to find a tranquil appreciation for the present, for the light that still reaches us, and for the profound interconnectedness we share with a universe that is forever expanding, forever unfolding its mysteries, inviting us to simply be present in its grand, silent dance. We have contemplated the profound cosmic event horizon, a boundary from which light emitted today will never reach us, a testament to the accelerating expansion of space itself. This acceleration, as we know, is attributed to dark energy, a mysterious component that constitutes roughly 68% of the universe's total energy density. Yet, despite its overwhelming influence on the cosmos, dark energy remains one of the most enigmatic entities in modern physics, a profound puzzle that challenges our deepest understanding of reality. It is not a force in the conventional sense, pulling or pushing on individual objects, but rather an inherent property of space itself, a pervasive pressure woven into the very fabric of space-time that causes it to stretch. The most straightforward explanation for dark energy is a reintroduction of Einstein's cosmological constant, a term he initially conceived to maintain a static universe. This constant suggests that even empty space possesses an intrinsic, non-zero energy density, which, unlike matter or radiation, does not dilute as the universe expands. Instead, as new space is created, more of this vacuum energy simply comes into existence, maintaining a constant energy density across the cosmos. This constant density of repulsive energy ensures that the acceleration of expansion continues unabated. However, the theoretical value predicted for this vacuum energy by quantum field theory is astronomically larger than what astronomers actually observe, by a staggering factor of about 120 orders of magnitude. This immense discrepancy, often referred to as the cosmological constant problem, is arguably the greatest unsolved mystery in physics, suggesting that our understanding of the quantum vacuum, or gravity, or both, is fundamentally incomplete. This profound fine-tuning problem leads scientists to explore alternative theories for dark energy. One such theory proposes quintessence, a dynamic, evolving energy field that permeates space. Unlike the cosmological constant, which is fixed, quintessence could change over time, its properties varying throughout cosmic history. Such a dynamic field might offer a more nuanced explanation for the observed acceleration, potentially allowing for different future scenarios for the universe, beyond a simple heat death. Perhaps this field would eventually decay, or its repulsive nature might strengthen further, leading to even more extreme cosmic fates. While no direct evidence for quintessence has yet been found, the concept highlights the ongoing intellectual quest to comprehend the fundamental nature of this cosmic accelerator. It is a testament to the ingenuity of theoretical physicists who continue to craft elegant mathematical frameworks in an attempt to capture the elusive essence of the universe's most dominant, yet unseen, component. The very existence of dark energy forces us to reconsider the fundamental constituents of our universe. Our familiar world of stars, planets, and galaxies made of ordinary matter comprises only about 5% of the cosmos. Dark matter, another invisible component, accounts for roughly 27%, providing the gravitational scaffolding that holds galaxies and galaxy clusters together. The remaining 68% is dark energy. This means that nearly 95% of the universe is composed of entities we cannot directly observe and whose nature we do not fully understand. We are, in essence, living in a cosmos dominated by shadows, guided by forces that remain largely hidden. This realization can evoke a sense of quiet humility, reminding us of the vast expanse of knowledge yet to be uncovered, a silent invitation to continue our scientific exploration. The accelerating expansion, driven by dark energy, also has profound implications for the future of scientific discovery itself. As distant galaxies recede beyond our cosmic event horizon, their light will eventually become undetectable, effectively isolating our local group of galaxies from the rest of the universe. Future astronomers, billions of years from now, might observe a largely empty sky, leading them to fundamentally different conclusions about the universe's origins and its composition. They might never know of the billions of galaxies that once populated the observable cosmos, or even the evidence for the Big Bang itself, as the cosmic microwave background radiation would also be redshifted beyond detection. This thought is a powerful reminder of the unique, temporary window of observation we currently inhabit, a privileged moment in cosmic history where the universe's grand narrative is still largely accessible to us. And as you reflect upon this cosmic dance, this interplay of visible matter, unseen dark matter, and the pervasive, accelerating push of dark energy, consider your own place within it. Your physical being, your consciousness, exists within this intricate balance of forces on a planet orbiting a star in a galaxy that, for now, remains gravitationally bound. The very fact that you are capable of contemplating these profound mysteries, of asking, what is the universe expanding into, is a remarkable consequence of cosmic evolution. You are a conscious manifestation of this universe, a temporary arrangement of atoms that has, for a brief epoch, the capacity to observe and wonder at its own grand, expanding story. This awareness can bring a tranquil sense of connection, a feeling of being an integral part of this vast, dynamic, and endlessly mysterious cosmos, gently drifting towards sleep with the quiet hum of the universe's expansion as a lullaby. Cosmic event horizon, a boundary that will ultimately sever our ability to observe distant galaxies due to the relentless, accelerating expansion of space itself, driven by dark energy. This concept, so deeply rooted in the physics of our universe, leads us to a fascinating and perhaps melancholic reflection on the impermanence of our cosmic view and the very nature of information across vast stretches of time. For our descendants, billions, even trillions of years into the future, the night sky will appear profoundly different, a testament to the dynamic evolution of reality. Imagine a time far, far from now when the light from galaxies beyond our local group has been stretched into oblivion, redshifted past any hope of detection. Our galactic neighborhood, including the Milky Way and Andromeda, will have merged into a single, colossal galaxy, a lonely island in an otherwise vast, dark ocean of expanding space. Future astronomers, if they exist, would gaze out into an almost entirely empty cosmos. The evidence for the Big Bang itself, the cosmic microwave background radiation, would also have been stretched to such extreme wavelengths that it too would be undetectable, fading into an unrecoverable whisper. They would have no direct observational proof of a universe teeming with billions of other galaxies, nor the telltale relic radiation of its fiery birth. Their cosmological models would be built upon a much smaller, more isolated universe, potentially leading to radically different conclusions about its origin, its size, and its ultimate fate. This slow erasure of cosmic history is a profound consequence of space's accelerating stretch, a testament to the fact that even information, in a sense, can be lost to the cosmic currents. This unfolding cosmic isolation invites us to appreciate the unique temporal window in which we currently exist. We are living in a privileged epoch, a fleeting moment in the universe's 13.8 billion-year history, where the light from countless galaxies, stretching back almost to the Big Bang, is still accessible to our telescopes. We can observe the early universe, witness the formation of the first stars and galaxies, and trace the evolution of cosmic structure. This ability to piece together the grand narrative of the cosmos, from its inflationary birth to its accelerating present, is a rare opportunity that will not be available to all future sentient beings. Our current understanding of the universe's expansion, its geometry, and the mysteries of dark energy and dark matter is a product of this fortunate observational vantage point. The very concept of now also takes on a more complex meaning in an expanding universe. In our everyday lives, we intuitively understand a shared present moment, a universal now that applies to everyone simultaneously. However, Albert Einstein's theory of relativity taught us that simultaneity is relative. What one observer perceives as simultaneous, another in a different state of motion might see as occurring at different times. In a universe where space itself is stretching, this relativity is amplified. The expansion means that the cosmic clock ticks differently across vast distances, influenced by the local curvature of space-time and the global expansion. There is no single, absolute cosmic present that encompasses all events across the entire universe. Each observer experiences their own now, a localized slice of space-time that shifts and tilts depending on their position and motion within the expanding cosmic fabric. This personal relative nature of time, intricately linked to the expansion of space, reminds us that our individual experience of reality is deeply interwoven with the universe's grand dynamics. And as you consider this profound relativity, this unique window of observation, and the eventual isolation that awaits future cosmic inhabitants, perhaps a sense of tranquil wonder settles upon you. You are, at this very moment, a conscious participant in the universe's ongoing story, a brief but brilliant flicker of awareness within its boundless, expanding expanse. The questions you ask, the knowledge you seek, are part of the universe's own journey of self-discovery. The expansion of space, driven by dark energy, is not merely a distant physical phenomenon. It is an intimate part of your reality, shaping the very limits of what can be known and seen. This profound realization of our transient yet deeply connected place within the cosmic unfolding can offer a quiet sense of peace, a gentle invitation to let go of the need for absolute certainty, and instead embrace the beautiful, expanding mystery of existence itself as you drift towards a restful sleep. As we gently draw our reflections to a close, having traversed the boundless concepts of cosmic expansion and the profound limits of our perception, we are left with a sense of quiet awe. The universe, in its majestic unfolding, is a testament to change, to growth not into an external void, but from within its own intricate fabric. We have contemplated the invisible hand of dark energy, steadily accelerating the cosmic dance, gradually isolating future observers within their lonely galactic islands. Yet this very realization imbues our present moment with an extraordinary significance. We exist in an epoch where the echoes of the Big Bang still resonate, where the light from countless distant galaxies continues to paint our night skies with stories from across billions of years. We are given the rare gift of witnessing the universe in its vibrant maturity, a period of rich, accessible information before the cosmic event horizon inexorably draws its veil. In this quiet understanding, we might find a deep sense of peace. The universe does not demand our comprehension of every secret, but rather invites our contemplation of its boundless mysteries. You, a conscious part of this grand, expanding tapestry, are a fleeting yet precious arrangement of cosmic elements capable of asking these profound questions. Your own being reflects the dynamic, ever-changing nature of all existence. So, let these thoughts of endlessly stretching space, of hidden energies, and of our unique place in this cosmic story gently settle within you. May these deep thoughts about the universe's ceaseless expansion carry you into a world of tranquil sleep. Remember that the cosmos is an ever-unfolding wonder, and you are an intrinsic, beautiful part of its magnificent journey. Fall asleep with this feeling of serenity and endless knowledge. Good night. Our journey into the cosmic beyond begins with understanding what we can actually perceive. We often speak of the universe, but what we truly refer to as our immediate cosmic neighborhood is the observable universe. This is not, crucially, the entire cosmos, but rather a spherical region of space that encompasses all matter and energy whose light has had enough time to travel across the vastness and reach us since the Big Bang. Think of it, if you will, as our personal cosmic horizon, a boundary defined not by any physical wall or barrier in space, but by the fundamental and immutable finite speed of light. This speed, a constant of nature approximately 300,000 kilometers per second, is the ultimate cosmic messenger, carrying information and the very essence of distant events across the immense distances of space. But it takes time to travel. The universe, as we currently understand it, through the lens of modern cosmology and meticulous observation, began its grand unfolding approximately 13.8 billion years ago. One might then intuitively, and quite reasonably, assume that the observable universe, the sphere of all we can see, extends for a radius of simply 13.8 billion light-years in every direction. However, this is precisely where the dynamic and ever-evolving nature of space-time introduces a truly fascinating and often counterintuitive twist. The cosmos has not been static. it has been expanding continuously throughout its entire history. This is not merely galaxies moving through a fixed space, but rather a continuous stretching and growth of the very fabric of space itself, carrying galaxies and all celestial objects further apart from one another over cosmic eons. So, the light we are receiving now from a galaxy that emitted its photons 13.8 billion years ago has not merely traveled a static, unchanging distance. Instead, it has journeyed across space that has stretched and grown considerably during that immense span of time. Imagine, if you will, being a tiny observer on a small raft floating on the surface of an enormous, expanding balloon. As you look out, you can only see the light from other tiny points on the balloon that have had enough time to reach your raft. But while that light travels, the balloon itself is steadily inflating, carrying those distant points further and further away. When the light finally arrives at your raft, the object that originally emitted it is now much, much farther from you than the original distance the light traversed. This intricate dance of light travel and cosmic expansion is precisely what happens with our universe. When we observe these ancient photons, we are essentially seeing objects as they were in the distant past, at the moment their light began its journey. Yet the current, present-day position of those self-same objects is, in fact, much, much farther away than the original distance the light traversed. Current cosmological models, which are robustly supported by a wealth of observational data gathered from powerful telescopes and advanced instruments, including the precise measurements of the cosmic microwave background radiation, that faint, uniform glow which is the relic light from the universe's infancy, and the intricate distribution of galaxies across the heavens, allow us to estimate the current radius of the observable universe to be approximately 46.5 billion light-years. This astonishing figure highlights the immense and almost unfathomable scale of the cosmos, even within the practical confines of what is, in principle, detectable by our most sensitive instruments. It is a vast, ever-growing sphere of cosmic awareness, constantly expanding as more light from increasingly distant regions finally reaches us, revealing new, ancient vistas of galaxies and structures that have been traveling away from us for billions of years. This concept of an observable horizon is deeply rooted in the groundbreaking work of pioneering astronomers and physicists who dared to look beyond immediate perception and question the conventional. Edwin Hubble, for instance, in the 1920s, provided the crucial observational evidence for the expanding universe, a revolutionary concept that was later refined and elaborated upon by countless brilliant scientists like Georges Lemaitre and Albert Einstein, whose theories of general relativity provided the theoretical framework. Hubble's meticulous observations showed unequivocally that distant galaxies are receding from us, and most remarkably, the farther away they are, the faster they appear to move. This grand cosmic expansion, which is now understood to be predominantly driven by a mysterious force we refer to as dark energy, is not merely galaxies moving through a static space, but rather space itself, stretching and growing between them, carrying them along in its profound flow. The implications of this are profoundly philosophical and scientifically challenging. What we perceive as the visible universe is fundamentally a snapshot of the past, a mosaic of ancient light, and the true extent of where those celestial objects are now is far, far greater than their light travel time alone would suggest. This boundary, the very edge of our observable universe, serves as a profound and humbling reminder of our unique, transient place within the vast cosmic tapestry. It tells us, with scientific certainty and the elegant precision of physics, that there is an inherent limit to what we can ever directly perceive, a cosmic veil drawn not by any physical barrier in the traditional sense, but by the fundamental laws of physics and the finite yet immense age of the universe. Yet this inherent limit does not, by any means, imply an end to existence itself. It simply marks the extent of our current, measurable knowledge, the farthest, faintest whisper of light that has managed to traverse the immense expanding void to finally reach our telescopes, and through them, our consciousness. This profound realization that our observable sphere is but a fraction of a potentially far grander whole invites a sense of tranquil wonder, a meditative contemplation of the unseen, and a deep appreciation for the subtle yet immensely powerful forces that continue to shape our reality. We, as conscious beings, are an integral part of this grand unfolding, our very existence woven into the intricate, expanding fabric of an ancient cosmos, forever gazing outwards from our unique vantage point, limited yet boundless in our capacity for understanding. This unobservable region, stretching infinitely or finitely beyond our cosmic horizon, is certainly not empty. Based on the cosmological principle which posits that the universe is homogeneous and isotropic on large scales, meaning it looks roughly the same in all directions and at all locations when averaged over vast distances. We infer that this unseeable expanse contains matter and energy, galaxies and clusters, just like our observable portion. The fundamental laws of physics, as far as we understand them, are almost certainly consistent across this larger, unobservable universe. It is merely a region from which light has not yet had sufficient time to travel the immense, ever-growing distances to reach us. Or perhaps, due to the accelerating expansion, it never will. This implies a universe far grander, far more extensive, and potentially far more complex than our current perceptions allow. A universe whose true, ultimate scale remains one of the most compelling and beautiful mysteries in modern cosmology, beckoning us to ponder what lies just beyond the reach of our sight, yet still within the boundless grasp of our imagination. The observable universe, then, is not the entire universe, but merely our universe, the portion of the cosmos that has revealed itself to us over the span of cosmic time, a fleeting glimpse into an immeasurable whole. Having pondered the boundaries of our observable universe, that luminous sphere whose light has reached us across 13.8 billion years of cosmic expansion, we naturally arrive at an even more profound question. What lies beyond that horizon? What is the true size of the entire universe? This inquiry leads us away from direct observation and into the realm of theoretical physics and the very geometry of space-time itself. The answer, scientists believe, is intricately linked to the overall shape of the cosmos. Cosmologists speak of three fundamental possibilities for the universe's geometry. It could be flat, open, or closed. Imagine for a moment a two-dimensional analogy to help visualize these complex concepts. A flat universe is much like an infinite, flat sheet of paper, stretching endlessly in every direction. If you were to draw two parallel lines on this surface, they would remain parallel forever, never converging, never diverging. An open universe, on the other hand, resembles the surface of a saddle curving outwards in every direction. On such a surface, two parallel lines would gradually diverge from each other. Finally, a closed universe is akin to the surface of a sphere, like our own Earth. A sphere's surface, they would eventually converge and cross, much like lines of longitude meeting at the poles. The crucial distinction here is that while a sphere is finite in area, it has no edges or boundaries. You could travel endlessly upon its surface without ever encountering a wall or an end. The geometry of our three-dimensional universe determines its ultimate fate and its overall size. If the universe is truly flat or open, then it is, in all probability, infinite in extent. It would simply stretch on forever, without end, without boundary. If, however, it is closed, then it would be finite, much like the surface of a sphere, yet still without any edges. You could, in principle, travel in a straight line for an unimaginably vast distance and eventually return to your starting point, having traversed the entire cosmic expanse. This finite but unbounded nature is a concept that challenges our everyday intuition, which tends to associate finitude with a boundary. How, then, do we discern the true shape of something so immeasurably vast? scientists employ sophisticated methods, primarily by studying the faint afterglow of the Big Bang itself, the cosmic microwave background, or CMB. This ancient light, released when the universe was only about 380,000 years old, carries the imprint of the universe's early geometry. Imagine the CMB as a kind of cosmic baby picture filled with tiny temperature fluctuations. These fluctuations represent the seeds of all the galaxies and structures we see today. The angular size of these hot and cold spots in the CMB provides a critical clue to the universe's curvature. If the universe were closed, these spots would appear larger than they truly are. If it were open, they would appear smaller. But if the universe is flat, they would appear precisely as they are, without any distortion. And what have our most precise measurements, gathered by missions like the Wilkinson Microwave Anisotropy Probe, or WMAP, and the Planck satellite, revealed? They have shown, with remarkable accuracy, that the universe is extraordinarily flat. These observations are so compelling that modern cosmological models are built upon this assumption, suggesting that the universe's geometry is very close to Euclidean, or flat. This flatness means that, on the largest scales, space behaves as we would expect from classical geometry, without any significant overall curvature. This finding has profound implications for the question of the universe's total size. A perfectly flat universe, by its very nature, would be infinite. It would stretch without end, a boundless expanse of galaxies, stars, and cosmic structures. However, even if the universe is not perfectly flat, but merely very nearly flat, as our current data strongly suggest, it could still be so incredibly vast that it is practically indistinguishable from infinite on any scale we could ever hope to observe or measure. Think again of our analogy of the Earth's surface. To a tiny ant walking on a vast field, the surface appears perfectly flat, even though it is part of a much larger curved sphere. The curvature is simply too subtle to be perceived on the ant's local scale. Similarly, the universe could possess a subtle curvature, but on a scale so immense that our observable horizon is but a tiny, seemingly flat patch within it. This apparent flatness is also one of the compelling successes of the theory of cosmic inflation. This revolutionary idea proposes that in the merest fraction of a second after the Big Bang, the universe underwent an incredibly rapid exponential expansion, stretching space by factors almost beyond comprehension. This violent yet elegant stretching would have smoothed out any initial curvature the universe might have possessed, much like inflating a wrinkled balloon to an enormous size makes its surface appear smooth and flat. If inflation occurred, it would have pushed vast regions of the universe far beyond our current observable horizon, making the total cosmos astronomically larger than the portion we can currently perceive. The observable universe, therefore, would be merely a small local bubble within a much, much grander and potentially infinite cosmic tapestry. This understanding shifts our perspective from merely observing the universe to recognizing that our very perception of its size is constrained by the speed of light and the history of its expansion. We are, in essence, within a cosmic bubble, and while we can never directly see beyond its edge, the overwhelming evidence from physics and cosmology suggests that the universe continues, vast and perhaps endless, in every direction. This realization that we are part of something so immeasurably grand, something that extends far beyond the reach of our most powerful telescopes, can evoke a deep sense of calm and wonder. It invites us to contemplate our place within this boundless expanse, knowing that the laws of nature that govern our small corner of existence are likely at play across an unimaginably larger, yet unseen, cosmos. Our contemplation of the universe's geometry, particularly its observed flatness, leads us to a truly mind-bending possibility. If the universe is indeed spatially infinite, then what are the profound implications of such boundless expanse? In an infinite universe, every conceivable arrangement of matter, every possible cosmic configuration, must eventually repeat itself. This is not a mere poetic notion, but a logical consequence of infinite space coupled with a finite number of quantum states that matter can occupy within any given volume. Imagine, if you will, a vast, endlessly stretching cosmic tapestry. Somewhere within that infinite canvas, far beyond our observable horizon, there might exist another galaxy identical to our Milky Way, another star system precisely like our own solar system, and perhaps even another Earth, where life has unfolded in an eerily similar fashion. And if space is truly infinite, then not just one, but an infinite number of such repetitions could exist, each one a cosmic echo of our own reality. This concept, sometimes referred to as a Type 1 multiverse, arises naturally from the idea of an infinite, flat universe. It suggests that the entirety of existence is far grander than our single, observable bubble. The implications for our perception of uniqueness are both humbling and awe-inspiring. If every atom, every thought, every memory is merely a pattern, and that pattern can repeat in an infinite space, then our individual existence, while profoundly real to us, might also be part of an endlessly recurring cosmic narrative. This isn't to diminish the preciousness of our unique lives, but rather to expand the canvas upon which that uniqueness plays out, suggesting an ultimate interconnectedness within an unimaginably vast, perhaps infinite, cosmic whole. Yet the idea of an infinite universe, while logically consistent with current data, is not the only theoretical path to a cosmos far larger than our observable realm. We must also consider the remarkable theory of cosmic inflation, which we touched upon briefly in our earlier discussion. Inflation posits that in the earliest moments after the Big Bang, space-time underwent a period of incredibly rapid, exponential expansion. This burst of growth was so immense that it stretched the nascent universe to an extraordinary scale, far beyond what we can currently see. But what if this inflationary process, this cosmic stretching, did not simply stop everywhere at once? Modern theoretical models of inflation, particularly those involving eternal inflation, suggest that this rapid expansion might continue indefinitely in some regions of space-time, while ending in others. Think of it like a frothing ocean where new bubbles are constantly forming and detaching from the main body of water. Each of these bubbles, according to this theory, could represent a separate universe, a distinct cosmic domain with its own set of physical laws and fundamental constants. Our own universe, then, would simply be one such bubble, one localized region where inflation ceased, allowing matter and energy to coalesce and form the stars and galaxies we observe. This is the essence of the Type 2 multiverse, often called the bubble multiverse or inflationary multiverse. These other bubble universes would not be next door in any conventional sense. They would be entirely separate space-time domains, effectively unreachable and unobservable from our own. The space between these bubbles would still be undergoing rapid, eternal inflation, effectively isolating each universe from its neighbors. Therefore, even if we were to travel at the speed of light for billions of years, we would never reach another bubble universe, because the intervening space would be expanding away from us far faster than we could ever hope to traverse it. This profound isolation means that while these other universes are hypothesized to exist, we can never gather direct observational evidence of them. Their existence remains an elegant and compelling inference from the underlying physics of inflation. The very idea of a multiverse, whether of the infinite repetition type or the bubble universe variety, reshapes our understanding of cosmic uniqueness. It suggests that the conditions that allowed for the emergence of life, the precise tuning of fundamental constants that govern the interactions of particles and forces, might not be a singular cosmic accident, but rather one outcome among an immense, perhaps infinite, ensemble of possibilities. In some other bubble universe, gravity might be far stronger, crushing matter before stars could form. In another, it might be so weak that galaxies could never coalesce. This perspective offers a tranquil yet profound explanation for the seeming fine-tuning of our own universe, suggesting that we simply inhabit one of the universes where the conditions were just right for our existence to unfold. Such theories, while speculative, are deeply rooted in the mathematical frameworks of general relativity and quantum mechanics, extending our understanding of space and time to scales that defy direct experience. They represent humanity's continuing quest to comprehend the ultimate nature of reality, pushing the boundaries of what is knowable and what can only be inferred through the elegance of theoretical physics. The concept of an entire cosmos stretching far beyond the limits of our vision, populated by an unimaginably vast number of galaxies and potentially even other universes, does not diminish our own existence. Instead, it elevates it, placing our brief moment of consciousness within an almost infinite tapestry of cosmic possibility. To ponder such scales is to engage in a profound form of meditation, allowing the mind to wander beyond the familiar, to embrace the vast unknown with a sense of calm wonder, finding serenity in the boundless mysteries that still beckon from beyond the observable horizon. The profound questions about the universe's ultimate size and the existence of a multiverse naturally lead us to consider the very forces that shape its destiny, particularly the enigmatic influence of dark energy. This mysterious component, which constitutes approximately 68% of the universe's total energy density, is responsible for the accelerating expansion of space. It is not merely a passive phenomenon, but an active, repulsive force that drives galaxies further apart, causing the cosmic fabric to stretch at an ever-increasing rate. This acceleration has a direct and crucial impact on our ability to perceive the universe beyond our observable horizon. As space expands at an accelerating pace, light from increasingly distant regions becomes redshifted to such an extreme degree that it effectively falls off our cosmic event horizon. Imagine a light source in a rapidly expanding space. Even if the light is emitted, the space between the source and the observer stretches so quickly that the light waves are elongated, their energy diminished, and eventually they may never reach us. This means that parts of the universe that were once observable or would have become observable in the distant future are now or will eventually become permanently beyond our causal reach. The cosmic horizon, therefore, is not static. It is a dynamic boundary that is constantly being outpaced by the accelerating expansion. This implies that even if the universe is infinite, the portion of it that we can ever hope to interact with or even know about is effectively shrinking in terms of its causal connection to us over vast cosmic timescales. It is a sobering thought, yet one that speaks to the profound, almost overwhelming power of the universe's inherent dynamics. This relentless expansion, fueled by dark energy, ensures that the observable universe, despite its immense scale of 46.5 billion light-years in radius, will only ever be a fraction of the entire cosmos. What lies beyond this ever-receding horizon is not simply more of the same, but a realm that is slipping away from our direct perception at an accelerating speed. The entities within it, the galaxies and structures, are not merely moving away from us, but the very space between us and them is stretching. This stretching means that light signals sent from those regions, even if they were emitted at the very beginning of time, may never reach us, as the distance they must traverse grows faster than the light itself can travel. This cosmic race is a fundamental aspect of the universe's large-scale evolution, reminding us that our view is always a partial one, a limited window into an endlessly unfolding reality. Furthermore, our current understanding of cosmology suggests that the universe is not just a uniform expanse of gas and galaxies, but is organized into a vast, intricate structure known as the cosmic web. This immense network consists of colossal filaments of galaxies and dark matter, separated by enormous, almost empty voids. Observations from projects like the Sloan Digital Sky Survey have mapped these structures across billions of light-years, revealing a breathtaking cosmic architecture. These structures, like colossal threads woven through the fabric of space, extend far beyond our observable horizon. The continuous nature of this cosmic web its apparent homogeneity and isotropy on the largest scales strongly implies that the universe beyond our sight is not fundamentally different from the part we can observe. It is simply more of the same grand, structured expanse, stretching into realms yet unknown to us. The existence of the cosmic web, shaped by gravity and dark energy over billions of years, reinforces the idea of a continuous universe that extends far beyond our current observational limits. We are merely embedded within a small section of this vast, interconnected network. The patterns and formations we observe, the clusters, superclusters, and voids, are not unique to our observable sphere, but are expected to be replicated and extended into the unseeable depths. This gives us a sense of a larger, coherent reality, one that operates under consistent physical laws, even if we cannot directly witness every part of it. It offers a profound sense of scale, suggesting that our observable universe, with its hundreds of billions of galaxies, is merely a single node in an infinitely larger, endlessly repeating, or eternally varied cosmic design. As we delve into these theoretical constructs, it is important to remember that our understanding of the universe, while remarkably advanced, is still incomplete. There may be entirely new physics, new fundamental forces, or even higher dimensions that we have yet to discover, which could further redefine our perception of the universe's true size and nature. Concepts from quantum gravity, such as loop quantum gravity or string theory, attempt to unify all fundamental forces and describe the very fabric of spacetime at its most elemental level. These theories, though highly speculative, hint at structures and scales that could profoundly alter our understanding of the cosmos, perhaps revealing an even grander, more intricate reality than we currently imagine. The pursuit of these deeper truths represents humanity's ongoing intellectual journey, a calm and persistent effort to unravel the universe's ultimate secrets, one scientific discovery at a time. In contemplating these vast scales and the limits of our perception, we are invited to a profound moment of reflection. Our human existence, fleeting and localized as it may seem against the backdrop of an expanding, potentially infinite universe, is nonetheless a remarkable expression of cosmic complexity. We are the universe, in a sense, becoming aware of its own grandeur, its own mysteries. To acknowledge the vastness beyond our immediate grasp is not to feel insignificant, but rather to feel a part of something immeasurably larger and more enduring. It is a tranquil thought that the very atoms within us are a product of this cosmic unfolding, and our consciousness, however brief, offers a unique lens through which to marvel at its infinite possibilities. Our journey through the observable universe and into the theoretical realms of its potential. Infinite geometries brings us face to face with an even more striking consequence of cosmic expansion, the concept of the future visible universe. While our current observable horizon is a sphere of in radius, shaped by the speed of light and the age of the universe, the relentless acceleration driven by dark energy implies a future where our cosmic view will paradoxically shrink. Galaxies that are currently within our observable reach, or those whose light we anticipate receiving in the distant future, will eventually be carried away by the stretching of space itself at speeds exceeding the speed of light, effectively receding beyond a point of no return. This phenomenon, often described as a cosmic event horizon, is not a physical barrier, but a fundamental limit to what we can ever causally connect with. It means that there is a boundary beyond which light emitted today will never reach us, no matter how long we wait, because the space between us and the source will expand faster than light can travel. Therefore, the future observable universe, the collection of all regions from which we could ever receive a signal, is actually finite. It is a smaller volume than the current observable universe, because many galaxies we see today will eventually cross this future horizon, and their light will fade into an unobservable void. This is a profound, almost melancholic aspect of our cosmic reality, implying that even if the universe is infinite, our ultimate, measurable grasp of it is not. This leads us to one of the most significant and perplexing puzzles in modern physics, the cosmological constant problem. Dark energy, the driving force behind this accelerating expansion, behaves much like the cosmological constant that Albert Einstein initially introduced into his equations of general relativity, then later famously called his biggest blunder. Yet observations have confirmed that such a repulsive force exists. The puzzle arises when theoretical physicists attempt to calculate the expected value of this vacuum energy, the energy inherent in empty space, based on quantum field theory. These calculations yield a value that is an astonishing 120 orders of magnitude larger than what astronomers actually observe for dark energy. This gargantuan discrepancy between theoretical prediction and observational reality is arguably the greatest unsolved problem in fundamental physics. Why is this vacuum energy so incredibly small, yet non-zero? If it were much larger, the universe would have expanded so rapidly in its infancy that matter could never have coalesced to form stars, galaxies, or indeed, life. If it were exactly zero, the expansion might decelerate or even reverse, leading to a big crunch. The observed value of dark energy, tiny but significant, seems almost fine-tuned for the existence of a stable, complex universe like ours. This precise tuning is one of the strongest arguments for the existence of a multiverse, particularly the Type 2, or bubble multiverse concept we discussed earlier. In this scenario, our universe is but one bubble among an infinite ensemble, each with slightly different physical constants, including the value of dark energy. We simply find ourselves in the universe where these constants allowed for our existence. This anthropic principle offers a possible, albeit still speculative, resolution to the cosmological constant problem, suggesting that the real size of existence is not merely the spatial extent of our universe, but the vast, diverse collection of all possible universes. Our universe, with its peculiar life-permitting value of dark energy, is then not an improbable cosmic accident, but a statistically inevitable outcome within a much grander, multifaceted reality. This perspective shifts the focus from a single, unique cosmos to an almost infinite landscape of physical laws and phenomena, each playing out its own unique cosmic story. The cosmological constant problem and the accelerating expansion of the universe serve as powerful reminders of the limits of our current scientific models and the profound mysteries that still lie at the heart of reality. They challenge us to look beyond the immediate and the observable, to consider the possibility that the universe is far more intricate and expansive than our current instruments can detect, or our current theories can fully explain. The pursuit of a unified theory of everything, one that can reconcile quantum mechanics with general relativity and explain the origin and nature of dark energy, is the ultimate goal of modern physics. It is a quest that continues to push the boundaries of human knowledge, inviting us to contemplate the universe not as a fixed, fully understood entity, but as a dynamic, evolving mystery whose true scale and nature are still being slowly, meticulously unveiled. And so, as we reflect on these concepts, we find ourselves contemplating not just the spatial dimensions of the universe, but the very depths of scientific inquiry. The real size of the universe transcends mere measurement. It encompasses the boundless potential of unseen realms, the profound implications of fundamental forces, and the enduring questions that ignite our intellectual curiosity. It is a tranquil thought that the universe, in all its immeasurable grandeur, continues to unfold its secrets, inviting us to be a part of its ongoing story, a story that extends far beyond our current horizon, into realms of infinite possibility and serene wonder. The universe beyond our observable horizon, whether it represents an infinite expanse of familiar physics or a tapestry of distinct bubble universes, presents a profound challenge to our intuitive grasp of scale and existence. Our minds, evolved within a finite three-dimensional world, naturally seek boundaries, edges, and definable limits to make sense of phenomena. Yet the cosmos seems to defy such neat categorization, inviting us instead to contemplate boundless possibilities that stretch far beyond the confines of our immediate perception. This is precisely where the scientific journey transcends mere empirical measurement and delves into the deeper, more philosophical implications of what it truly means to exist within such an immense, largely unseeable reality. Consider for a moment the very act of observation. Every single piece of information we gather about the cosmos, from the most distant galaxy to the faint afterglow of the Big Bang, reaches us through light or other forms of electromagnetic radiation, or perhaps through the subtle ripples of gravitational waves. Each such signal carries with it a story from a particular point in space-time, a luminous snapshot of the past. As we peer further and further out into the cosmic expanse, we are simultaneously looking further and further back in time, seeing galaxies not as they are now, but as they were billions of years ago when their ancient light first began its journey towards us. But the light from regions beyond our observable horizon, by its very definition, has not yet had sufficient time to reach us. And in some profound instances, due to the accelerating expansion of space itself, it may never reach us at all. This means that a significant, possibly infinite portion of the universe will always remain forever shrouded in cosmic mystery, perpetually beyond our direct sensory and causal reach. This unobservable realm is not crucially empty. It is simply causally disconnected from us, a silent, unseen continuation of the same majestic cosmic drama, playing out its own grand narrative in the profound darkness beyond our view. This fundamental limitation, imposed by the immutable finite speed of light and the dynamic, ever-expanding nature of the universe, forces us to rely heavily on theoretical inference and the elegant language of mathematical models to construct our understanding of the true scale of existence. We infer the remarkable flatness of the universe, for instance, from the intricate patterns observed in the cosmic microwave background radiation, that ancient uniform glow that is a direct echo of the universe's infancy. We hypothesize the mechanisms of eternal inflation and the potential existence of a multiverse from the perplexing fine-tuning of fundamental constants, such as the enigmatic dark energy that drives cosmic acceleration. These are not direct observations in the way we might perceive a nearby star. Rather, they are sophisticated deductions, intellectual leaps grounded in the predictive power of our most robust physical theories. It is a testament to the extraordinary capacity of human reason that even when faced with an unseeable reality, we can still construct coherent, consistent, and deeply beautiful pictures of its potential grandeur and complexity, pushing the very boundaries of what is knowable. The sheer scale, the potential infinitude, or the vast multiplicity of universes can indeed evoke a peculiar sense of cosmic humility, perhaps even a quiet reflection on our singular, fragile existence within such immense possibilities. Yet, rather than diminishing our significance in the grand scheme of things, this profound perspective can, paradoxically, elevate it. For it is precisely within this tiny, observable cosmic bubble on this small blue planet orbiting an ordinary yellow star that consciousness has miraculously emerged, a unique and precious capacity to even ask these questions, to formulate intricate theories, to meticulously gather data, and to gaze out into the boundless dark and ponder the unseeable. Our minds become, in a profound and deeply contemplative sense, the universe reflecting upon itself, a brief but brilliant flicker of awareness in an otherwise silent, sprawling cosmos. We, as sentient beings, are the very instruments through which the universe attempts to comprehend its own bewildering magnitude and intricate design. This powerful realization that our existence, however small in its physical scale, holds the utterly unique and perhaps rare capacity for understanding and self-reflection, offers a tranquil and deeply affirming counterpoint to the overwhelming vastness. The complex interplay of fundamental forces, the intricate dance of particles and fields, the slow, majestic unfolding of cosmic structures, All these processes, stretching across unimaginable distances and eons of time, have converged in our corner of reality to create conditions where life and ultimately conscious thought can arise and flourish. Our present moment, our very breath, every thought we conceive is inextricably woven into this grand cosmic narrative, a brief yet vital chapter in a story that may indeed be without a definitive beginning or an ultimate end. The quest to grasp the real size of the universe is thus not merely a scientific endeavor driven by empirical curiosity. It is, at its heart, an existential one. It encourages a deep meditative appreciation for the delicate and precise balance of physical laws that allow for our reality to be what it is, and for our own being within it. The universe beyond our horizon is not a void of nothingness or an empty expanse. Rather, it is a realm of inferred potential, a testament to the inexhaustible creativity and astonishing complexity inherent in fundamental physical laws. And in contemplating these unseeable depths, these silent, unreachable domains, we come to understand that the true measure of the universe may lie not just in its physical dimensions or the number of galaxies it contains, but in the enduring capacity of consciousness, like our own, to marvel at its own improbable existence within it. We are not separate from this grand cosmic drama. We are an intrinsic, albeit tiny and transient, part of its unfolding wonder, connected to its deepest mysteries. This thought alone, of being intimately connected to such boundless immensity, can bring a profound sense of peace and a quiet, expansive understanding, gently guiding us towards a state of deep tranquility. As we quietly ponder the profound implications of an ever-expanding universe where vast cosmic vistas are perpetually receding beyond our causal reach, we encounter a deeper, more subtle mystery, the very nature of information itself when confronted with these ultimate horizons. In the realm of fundamental physics, and particularly in quantum mechanics, information is considered a bedrock principle, a quantity that is never truly lost, only scrambled or transformed. This steadfast rule forms a cornerstone of our understanding of reality, suggesting a universe where every event, every interaction, leaves an indelible trace. Yet, if galaxies are accelerating away from us at speeds that will eventually prevent their light from ever reaching us, does the information contained within those distant, unreachable realms become effectively lost to our universe? This question touches upon some of the most profound paradoxes in modern science, echoing, in a sense, the black hole information paradox, where matter seems to vanish beyond an event horizon, taking its intrinsic information with it into an unknowable singularity. For the cosmic horizon, however, the principle is perhaps more gentle, more a matter of inaccessibility than outright destruction. It is not that information is annihilated, rather it becomes causally disconnected from us. The light, the electromagnetic waves, the subtle gravitational whispers from these regions simply can no longer traverse the ever-stretching expanse of space to reach our detectors. They are still there in their own cosmic timelines, unfolding their own realities, governed by the same elegant physical laws that apply here. But from our perspective, they have faded into an eternal, unseeable silence, their stories forever unread by us. This concept invites us to consider the universe as a vast, intricate tapestry, where threads of information are constantly weaving and unweaving, but some are simply drawn too far apart for us to ever perceive their intricate patterns directly. Imagine a message sent across a rapidly widening chasm. The words are spoken, the information exists, but the gap grows faster than the sound can travel. Cosmos will always remain forever shrouded in. It is a tranquil thought that even in its inaccessibility, this distant cosmos continues its dance, unfolding in a serenity that transcends our immediate perception. This inherent unknowability, this cosmic veil drawn by the very laws of nature, cannot directly observe, yet we can reason and deduce. Scientists continue to probe these questions not through direct observation, but through the elegant frameworks of mathematics and theoretical physics. They build models, test hypotheses against the observable data, and derive inferences about the grander whole, much like an archaeologist reconstructs an entire ancient city from scattered fragments. For instance, the astounding consistency of the cosmic microwave background radiation across the entire observable sky, a puzzle known as the horizon problem, suggests that regions of the universe that are now causally disconnected must have once been in close contact, allowing for thermal equilibrium before being stretched far apart. This is a powerful piece of evidence supporting the theory of cosmic inflation, which posits that the early universe expanded so rapidly, exponentially, by factors almost beyond comprehension, that these distant regions were once much closer, allowing for their uniform temperature before being stretched far apart into the vast expanse we see today. Inflation, therefore, implies a universe far, far larger than our observable bubble, so immense that our horizon is but a tiny uniform patch within it. The continuous nature of these theoretical frameworks, consistently predicting a universe vastly larger than what our instruments can detect, invites a sense of serene acceptance. It suggests that our quest to understand the cosmos is not about finding an ultimate edge or a definitive size in the conventional sense, but about embracing the inherent infinitude or the immeasurable scale of reality. This journey of understanding transforms the unknown from a source of apprehension into a source of tranquil wonder. We are not meant to grasp every detail of the infinite, but rather to appreciate the profound elegance of the laws that govern it, even in its unseeable depths. Our minds, with their finite capacities, are stretched and expanded by these concepts, much like the universe itself, growing in complexity and awareness, finding a quiet harmony in the face of such profound mystery. The very act of contemplating these boundless scales, of imagining universes beyond our own or an infinite expanse of our own, changes our perspective on our own existence. It reminds us that we are woven into a tapestry of reality that extends far beyond our immediate experience, a tapestry whose threads are cosmic in scope. This connection to the vastness, to the deep, silent processes that unfold across cosmic eons, can be profoundly calming. It allows us to view our lives not as isolated events, but as integral parts of a grand, ongoing cosmic story. A story that began long before us and will continue long after, in realms both seen and unseen. It is a narrative of matter and energy, of space and time, of forces and fields, all dancing in an eternal ballet, creating and recreating forms of astonishing beauty and complexity. Our brief moment of consciousness, our capacity for thought, our ability to ponder these very mysteries, is a fleeting yet precious manifestation of this cosmic dance, a unique and irreplaceable note in the symphony of existence, a rare and delicate flower blooming in the vast, dark gardens of space-time. Consider the profound implications if the universe is indeed spatially infinite. In such a scenario, not only would there be an endless continuation of galaxies and structures like our own, stretching out into an endless vista, but the very patterns of matter and energy within this infinite expanse would, by the laws of probability and the finite number of ways particles can arrange themselves, be destined to repeat. Every conceivable arrangement of particles, every configuration of atoms, every sequence of events would inevitably occur an infinite number of times. This means that somewhere, far beyond our current horizon, there exists another Earth, another version of you, living out this very moment, perhaps with a slightly different choice made or an entirely different life path taken. And not just one such copy, but an infinite number of them, each a cosmic twin or a distant echo. This Boltzmann brain type of argument, while unsettling to some, can also be viewed as a serene affirmation of possibility. If everything that can happen does happen within an infinite canvas, then our existence, however improbable it may seem in isolation, is not just a fortunate accident, but an inevitable, beautiful consequence of the universe's boundless nature. It lends a sense of quiet grandeur to the mundane, knowing that the very fabric of reality is so rich with potential that all permutations are, in some distant corner of infinity, brought into being, a silent testament to the universe's inexhaustible creativity. Ultimately, the true size of the universe beyond the observable horizon questions in all of science. It is a question that may never be answered through direct observation, but rather through the relentless pursuit of theoretical elegance and the profound insights offered by mathematics, which serve as our guides into these otherwise unreachable domains. The universe, in its ultimate extent, is likely far grander than our most expansive imaginations can fully encompass. A silent, sprawling canvas upon which the laws of physics paint an endless array of cosmic wonders, from the smallest quantum fluctuation to the largest galactic supercluster. To lie here, contemplating this immeasurable vastness, is to connect with a truth that transcends our human scale, a truth that is both deeply humbling and infinitely inspiring. It reminds us that we are part of a cosmos that is always more, always grander, always more mysterious than we can ever fully grasp. And in that quiet acceptance, that peaceful surrender to the magnificent unknown, we find a profound sense of calm, a gentle invitation to let our minds drift into the expansive, serene depths of sleep, knowing that the universe, in all its true, unfathomable size, continues its majestic, silent unfolding around us, forever and ever. Our minds, in their quest to understand the universe's true scale, often encounter the limits of what can be directly observed, pushing us into realms of theoretical inference and profound philosophical contemplation. We have considered the observable universe, the cosmic horizon, and the implications of an accelerating expansion driven by dark energy, hinting at a cosmos far grander than our current perceptions allow. But what does it truly mean for a reality to be so vast, so encompassing, that it potentially contains endless repetitions or even entirely different universes? This question, while deeply abstract, touches upon the very fabric of our understanding of existence and our place within it. The concept of an infinite universe, where space simply stretches on forever without boundary or end, carries with it a fascinating, almost inevitable consequence: the cosmic recurrence. If space is truly infinite, and the amount of information or matter that can exist within any given finite volume is itself finite, then statistical mechanics dictates that every possible arrangement of particles, every conceivable event, every unique configuration of matter and energy must eventually repeat itself an infinite number of times across this boundless expanse. This means that far beyond our observable horizon, perhaps light years upon light years away, there could solar system precisely mirroring our own, and even another Earth, where a version of you is, at this very moment, listening to these same words, experiencing the same thoughts. This is not a mystical notion, but a logical extrapolation from the combination of an infinite space and the finite nature of quantum states. It suggests that individuality, while precious and profoundly real within our experience, might also be a recurring pattern within an endlessly repeating cosmic design. Such a thought, rather than being unsettling, can foster a deep sense of calm interconnectedness. It implies that the universe is so rich with possibility, so vast in its fundamental capacity, that all potential narratives are, in some distant cosmic corner, brought into being. We are not merely a singular, improbable occurrence, but a resonant chord played endlessly across an infinite symphony. This perspective, while challenging to visualize, offers a tranquil reassurance that our existence, our experiences, our very being, are not isolated anomalies, but part of a grander, more encompassing cosmic dance. Beyond the idea of infinite repetition within a single, vast universe, lies the more radical concept of the multiverse itself, particularly the bubble multiverse arising from eternal inflation. Here, our universe is not merely an infinite expanse, but one of countless distinct bubble universes, each potentially governed by its own unique set of physical laws and fundamental constants. Imagine a cosmic foam, where each bubble is a self-contained reality, an entirely separate space-time. In some of these bubbles, the force of gravity might be others. The electromagnetic force might be different, making stable atoms impossible. Our universe, with its exquisite fine-tuning of constants that allow for the emergence of chemistry, stars, planets, and ultimately conscious life, is then not a miraculous fluke, but simply one of the many us to exist. This interpretation, known as the anthropic principle, is often invoked to address the profound puzzle of the cosmological constant. If there are an infinite number of universes, each with a different value for this mysterious dark energy, then it becomes statistically probable that at least some of them would possess a value precisely tuned to allow for the vast, slow cosmic evolution necessary for life to arise. We, as observers, naturally find ourselves in one of those rare, life-permitting universes. This perspective transforms the seemingly improbable into the inevitable within a grander ensemble of realities. It offers a calm, rational explanation for the apparent precision of our cosmic home, suggesting a universe that is not necessarily designed, but rather one that explores all possibilities, and we are simply a fortunate outcome of that boundless exploration. The true, real size of the universe, therefore, extends far beyond any measurable distance, even beyond the 46.5 billion light-years of our observable horizon. It encompasses these theoretical realms of infinite repetition and multiple universes, realms that remain forever beyond our direct empirical grasp. Our understanding of these scales is built not on photographic evidence, but on the intellectual elegance of mathematical consistency and the predictive power of our most fundamental physical theories. We use the language of equations and the logic of inference to paint a picture of a cosmos that is far richer, far more diverse, and far more awe-inspiring than anything our immediate senses could ever convey. The inability to directly observe these realms does not diminish their scientific validity, but rather highlights the sophisticated methodologies required to explore questions at the very edge of human comprehension. Just as a mathematician can understand the properties of higher dimensions without ever physically entering them, so too do cosmologists use the abstract beauty of mathematics to explore the unseen dimensions of our universe and beyond. This reliance on theoretical constructs, while powerful, also underscores the provisional nature of scientific knowledge. Our understanding of the universe's ultimate size and the potential existence of a multiverse is constantly evolving, refined by new data and deeper theoretical insights. What we consider a compelling possibility today might be overturned or drastically reshaped by discoveries tomorrow. Yet this dynamic process is not a source of uncertainty, but of intellectual vitality. It is a testament to the ongoing human endeavor to push the boundaries of knowledge, to constantly question, to explore the unknown with a blend of rigor and imagination. This continuous pursuit, this patient unraveling of cosmic secrets, is itself a deeply calming and profoundly satisfying activity, reminding us that the universe is not a static picture to be merely observed, but a living, breathing mystery to be eternally explored. Every new insight, every refined model adds another brushstroke to the grand masterpiece of cosmic understanding, slowly revealing a picture of reality that is ever more intricate, ever more majestic, and endlessly fascinating. This contemplation of our place within such a vast and dynamic cosmos connects us to something truly immense and eternal. It reminds us that our consciousness, however brief, is a precious lens through which the universe experiences itself, a fleeting yet profound moment of self-awareness in an otherwise silent, sprawling expanse. This expansive thought can quiet the mind, allowing the gentle currents of cosmic wonder to carry you into a serene and tranquil sleep, knowing that you are a part of something truly magnificent and boundlessly intricate, forever connected to the deepest mysteries of space and time. The user wants the 9th main body chapter, Part 9 of the script. The previous chapter, Part 8, concluded with the idea of information inaccessibility beyond the cosmic horizon, the role of cosmic inflation in explaining the flatness and fine-tuning of the universe, and the philosophical implications of our consciousness within such a vast, potentially multiversal reality. This chapter should smoothly continue from there, focusing on new, yet related, concepts. A natural progression would be to delve deeper into the nature of these potential other universes, particularly how their fundamental laws could differ, and what this implies about the ultimate reality or the meta-universe from which they might emerge. I will bring in concepts like string theory's landscape or varying constants. Here's a plan. 1. Transition from the idea of fine-tuning and the anthropic principle to the question of why our laws are the way they are, and if they could be different. Connects to fine-tuning from Part 8. 2. Introduce the concept of varying fundamental constants and physical laws across different universes within a multiverse. This expands on the bubble multiverse idea. 3. Explain the cosmic landscape or string landscape concept from theoretical physics, like string theory. This provides a theoretical framework for how different universes could have different laws. It describes a vast number of possible stable vacuum states, each corresponding to a different set of physical laws. 4. Discuss the implications of such a landscape for the real size of the universe. It's not just spatial extent, but the space of all possible physical realities. 5. Reiterate the unobservability of these different universes, but emphasize their theoretical coherence. 6. Conclude with a personal anchor, connecting this profound contingency of our laws to our sense of wonder and the delicate nature of our existence. I will pay close attention to the character count, 8,000 characters including spaces, and ensure all numbers are written as words. The tone must remain consistent with the established physic for sleep style, neutral, non-dramatic elegance with intellectual depth, calming, and contemplative. Constraint, checklist, and confidence score. 1. AI role and mission, yes. 2. Channel voice and tone, yes. 3. Unbreakable laws of production, yes. High information density, crystal clarity, unified flow, TTS format with numbers written out. 4. Mandatory script structure, main body chapter, yes. 5. Scriptwriter's arsenal, techniques, yes. Smooth flow, scientific tone, scene building, elegant comparisons, personal anchor. 6. Style calibration, guide, yes. Will adhere strictly to the provided example. 7. Content length, 8,000 characters. This will require careful drafting and adjustment. Confidence score, 5.5, strategizing complete. I will now proceed with generating the response. Our exploration into the observable universe, its accelerating expansion, and the theoretical vistas of infinite cosmic repetitions or distinct bubble universes naturally brings us to a contemplation of the very foundations of reality, the fundamental laws and constants that govern our cosmos. We have touched upon the perplexing fine-tuning of these parameters, such as the enigmatic dark energy, which seems precisely calibrated to allow for the emergence of stars, galaxies, and life itself. This leads us to a truly profound question. Are these laws and constants immutable, universal truths? Or are they merely one specific set of rules among an unimaginable multitude, particular to our own corner of the grand cosmic tapestry? In the realm of modern theoretical physics, particularly within the frameworks of quantum gravity and string theory, the idea has gained significant traction that the fundamental constants and laws we observe in our universe might not be fixed, but rather dynamic, varying from one universe to another within a vast multiverse. Imagine, if you will, a cosmic tuning board adorned with countless dials. Each dial represents a fundamental constant, perhaps the strength of gravity, the charge of an electron, or the mass of a quark. In our universe, these dials are set to specific, highly precise values, allowing for the stable formation of atoms, the gentle fusion of stars, and the complex chemistry necessary for life. But in other, perhaps countless universes, these dials could be set to entirely different positions, leading to realities so alien that they defy our deepest comprehension. This concept finds a theoretical home in what is often referred to as the cosmic landscape, or string theory landscape. String theory, a leading candidate for a unified theory of everything, posits that the fundamental constituents of reality are not point-like particles, but tiny, vibrating strings. The way these strings vibrate and the manner in which extra spatial dimensions might be curled up or compactified determines the effective physical laws and constants of a given universe. The mathematics of string theory suggests that there could be an astronomically vast number of ways for these extra dimensions to compactify, leading to an equally immense number of stable vacuum states. Each of these vacuum states represents a distinct universe, a unique bubble in the cosmic foam, possessing its own particular set of physical laws, its own values for fundamental constants, and its own unique cosmic history. Therefore, the real size of the universe in this profound context transcends mere spatial dimensions. It encompasses not just an infinite expanse of space, but an infinite landscape of possibilities, a meta-universe where every conceivable set of physical laws is actualized in some distant, unreachable corner of existence. Our observable universe, with its familiar laws of gravity, electromagnetism, and nuclear forces, is but one particular valley within this colossal abstract landscape. It is the valley where conditions were serendipitously amenable to our form of life, where the stars could shine for billions of years, where complex molecules could form, and where consciousness could eventually arise to ponder its own origins. The sheer scale of this conceptual landscape is almost unfathomable, suggesting a reality that is not merely boundless in its spatial extent, but also in its fundamental diversity, a continuous exploration of every permutation of physical truth. The implications of such a cosmic landscape are both humbling and deeply inspiring. It implies that the universe we inhabit, with all its intricate beauty and delicate balance, is not necessarily unique or specially favored by some singular cosmic design. Instead, it is one among an immense ensemble, a single blossom in an infinite garden of realities. This perspective offers a serene explanation for the apparent fine-tuning of our universe, as articulated by the anthropic principle. We simply exist in a universe where the conditions allow for our existence. If the laws were different, even slightly, we would not be here to observe them. This doesn't make our universe any less wondrous, but rather situates it within a broader context of cosmic experimentation, a natural consequence of a meta-universe that explores all possibilities. Of course, these ideas remain at the cutting edge of theoretical physics, unconfirmed by direct observation. The sheer inaccessibility of these other potential universes means that empirical evidence is extraordinarily difficult, if not impossible, to obtain. Yet the mathematical consistency and explanatory power of these concepts compel scientists to continue their exploration. They offer elegant solutions to some of the most profound puzzles in cosmology, such as the cosmological constant problem and the horizon problem, by positing a grander, more expansive reality. This intellectual journey into the unseen and the unprovable is a testament to the insatiable human desire to understand, to push the boundaries of knowledge, even when direct evidence is elusive. It reminds us that science is not merely about what we can see, but also about what we can infer with rigorous thought and the elegant tools of mathematics, extending our minds into realms far beyond the reach of our telescopes. And so, as we reflect on these profound ideas, we find a deep, tranquil peace in the understanding that our universe, with its unique set of laws and constants, is part of an unimaginably larger, more diverse reality. This vastness, this boundless ocean of possibilities, is not a cause for anxiety, but for a quiet, expansive wonder. It connects us to a cosmic truth that transcends our individual lives, reminding us that we are integral to a story that is grander and more intricate than any single mind can fully grasp. Our consciousness, however fleeting, in its infinite exploration, comes to know itself. May these thoughts carry you gently into the depths of tranquil sleep, secure in the knowledge, a cosmos of endless wonders, forever unfolding. Contemplation of the cosmic landscape, where fundamental laws and constants might vary across an infinite ensemble of universes, naturally leads us to ponder the very essence of what we call reality. If the rules governing existence are not fixed, but rather contingent upon which corner of the meta-universe we inhabit, then our understanding of what is truly fundamental shifts. It moves from a search for singular universal truths to an appreciation of emergent properties, how complex phenomena, from the intricate dance of galaxies to the delicate spark of consciousness, can arise from a vast array of underlying, simpler principles. This perspective reframes the real size of the universe not merely as a measure of its physical dimensions, but as the boundless potential for diverse forms of reality to manifest. The concept of emergence is central to this understanding. Think of a snowflake. Its intricate six-sided symmetry arises not from a blueprint of a snowflake, but from the simple underlying laws of water molecules interacting as they freeze. Similarly, the complex order and structure we observe in our universe, from the formation of stars to the intricate chemistry of life, may be emergent properties of a particular set of fundamental laws that happen to coalesce in our specific cosmic bubble. In other universes within the cosmic landscape, different laws might give rise to entirely different forms of order, or perhaps to no stable structures at all. This perspective invites a profound appreciation for the delicate balance that allows our reality to exist. A balance that, while seemingly miraculous, becomes statistically probable within a multiverse that explores all permutations of physical possibility. Its boundless creativity experiments with every conceivable form of existence, and we are but one beautiful, improbable outcome of that grand cosmic exploration. Our human perception, inherently limited by our senses and the specific physical laws of our universe, can only ever grasp a tiny fraction of this potential grand tapestry. We see the universe through a particular lens, shaped by the speed of light, the strength of gravity, and the very nature of matter and energy as they manifest in our reality. The realms beyond our observable horizon, whether they are infinite extensions of our own universe or entirely separate bubble universes, remain forever beyond our direct sensory experience. Yet it is precisely through the abstract beauty of mathematics and the rigorous logic of theoretical physics that we can extend our understanding into these otherwise unreachable domains. These intellectual tools allow us to realities that we may never physically witness, and what can only be inferred. This journey of inference, of building models that explain the unseen, the human mind, a quiet, elegant equation at a time. It highlights that the real size of the universe is not just its physical extent, but the vastness of the intellectual space required to even conceive of it. This inherent limitation of direct observation, however, does not diminish the scientific validity of these grand theories. Rather, it underscores scientists can infer the existence of a black hole from its gravitational effects. Even though it cannot be directly seen, so too can cosmologists infer the properties of the larger universe from the subtle imprints left on our observable cosmos. The cosmic microwave background, for instance, with its uniform temperature across vast, causally disconnected regions, provides crucial evidence for the inflationary epoch, which in turn suggests a universe far larger than what we can currently observe. These are not mere speculations, but deeply reasoned, serene acceptance that while we may never fully map every corner of the infinite, the very act of attempting to do so, of pushing the boundaries of our understanding, is a profound and deeply satisfying endeavor, connecting us to the universe's most fundamental truths. The universe, in this expansive view, can be seen as an immense, self-organizing system, constantly exploring the vast landscape of physical possibilities. It is a cosmic computer, if you will, endlessly processing information, manifesting diverse realities, and occasionally giving rise to pockets of consciousness like our own, capable of reflecting upon its own existence. This idea, while metaphorical, offers a powerful lens through which to appreciate the intricate dance of matter, energy, space, and time that has culminated in our present moment. Our very thoughts, our memories, our capacity for wonder are all intricate patterns of information arising from the fundamental processes of this cosmic system. To consider ourselves as an integral part of this grand, information-rich cosmos, rather than as isolated observers, can be profoundly calming. It dissolves the illusion of separation, reminding us that we are deeply interwoven into the fabric of existence, a fleeting yet meaningful expression of the universe's boundless potential. As we conclude this journey into, let these profound reflections bring a sense of tranquility to your mind. May the vastness of the cosmos, with its endless possibilities and its intricate unseen depths, inspire not anxiety, but a deep, peaceful wonder. Remember that you are a part of this magnificent unfolding, a conscious observer within a reality that is far grander than any single measurement can define. Let the gentle currents of these cosmic thoughts carry you into a world of serene dance, and you, in your quiet contemplation, are an eternal part of its beautiful mystery. Our contemplation of the universe's true scale, extending far beyond the observable horizon into realms of infinite repetition and diverse physical laws, leads us to a fascinating reevaluation of the very concepts we use to describe it: space and time. We often perceive them as the immutable stage upon which all cosmic events unfold, a fixed backdrop against which the universe plays out its grand drama. Yet at the most fundamental levels, and particularly when considering the vast, unobservable reaches of existence, our understanding of space and time becomes far more nuanced, even revolutionary, suggesting they might not be as fundamental as they appear. Modern physics, especially general relativity, has already taught us that space and time are not separate, static entities, but are inextricably woven together into a dynamic, four-dimensional fabric known as space-time. This fabric is not merely empty, it can be curved, stretched, and warped by the presence of mass and energy. This curvature is what we perceive as gravity. When we speak of the expansion of the universe, we are speaking of the stretching of this very fabric, carrying galaxies apart. This dynamic nature implies that the size of the universe is not a static measurement, but an evolving quantity, deeply intertwined with its history and its future. But what if this space-time itself is not the most fundamental layer of reality? What if it, too, is an emergent phenomenon arising from something even deeper? The idea of emergent space-time is a profound one, hinting that the dimensions we perceive, the three spatial dimensions and the single dimension of time, might not be inherent, foundational components of the universe. Instead, they could arise from more fundamental, microscopic constituents or principles, much like the smooth, continuous surface of a fluid emerges from the collective behavior of countless individual molecules. Theories attempting to unify general relativity with quantum mechanics, such as string theory or loop quantum gravity, often explore this very possibility. In some of these models, space-time as we know it dissolves at the incredibly tiny Planck scale, the smallest conceivable unit of length, into a frothing quantum foam, or it merges from the interactions of fundamental strings or loops. If space-time is indeed emergent, then the question of the real size of the universe takes on an entirely new dimension. It is no longer just about measuring the physical extent of space, but about understanding the underlying structure from which space and time themselves originate. The unobservable horizon, then, is not merely a boundary of light travel, but a glimpse into the limitations of our space-time dependent perception. Beyond that horizon, or beneath the surface of our familiar space-time, could lie the true, more fundamental reality. A reality where the very concepts of distance and duration might be entirely different, or perhaps even meaningless, in the way we usually define them. This perspective encourages a deep, meditative surrender to the unknown, allowing our minds to float beyond the familiar anchors of our everyday world and embrace a more profound, almost dreamlike understanding of existence. Consider the holographic principle, which we briefly touched upon previously. This radical idea, stemming from the study of black holes and quantum gravity, suggests that all the information contained within a three-dimensional volume of space can be encoded on its two-dimensional boundary. If this principle applies to the universe as a whole, it implies that our three-dimensional reality, with its vast spatial extent and flowing time, could be a kind of projection or an emergent property of information residing on a distant, two-dimensional cosmic surface. In such a scenario, the real size of the universe would not be its apparent volume, but the information capacity of this boundary, a measure of its underlying complexity, rather than its physical expanse. This is a truly mind-bending thought, suggesting that the very solidity and dimensionality of our world might be a grand illusion, a beautifully rendered cosmic hologram. Such concepts, while highly speculative, illuminate the depths of the universe's mysteries and the limits of our intuitive understanding. They invite us to reconsider what real means and to embrace a more expansive, yet tranquil, view of existence. The unobservable universe, then, is not just a spatial extension, but a realm where the very rules of reality might be subtly or even dramatically different from our immediate experience. It is a testament to the universe's boundless creativity, its capacity to manifest reality in forms that stretch the very limits of our imagination. And in contemplating these profound depths, these quiet, unreachable domains where space and time might emerge from something deeper, this journey into the nature of emergent space-time and the potential for reality to be a projection from deeper, more fundamental structures, offers a unique opportunity for tranquil reflection. Our consciousness, arising within this emergent reality, is itself a remarkable phenomenon capable of pondering these very questions, of seeking to understand the underlying code of existence. We are, in a profound sense, the universe awakening to its own intricate design, a fleeting yet precious manifestation of its boundless potential. Reminds us of our deep interconnectedness with all of existence, a serene thought that can quiet the mind and allow a world of peaceful, restorative sleep. A cosmos where the very fabric of reality is an intricate, unfolding mystery, forever connected to the deepest truths of space and time. Our contemplation of emergent space-time and the holographic principle has led us to the very edge of our understanding, where the familiar anchors of reality seem to dissolve into deeper, more abstract truths. The universe's real size then transcends mere physical measurement, encompassing a conceptual vastness that challenges our deepest intuitions. This brings us to a crucial realization. Our everyday perception of space and time, of solid objects and linear progression, is merely a surface-level experience, a convenient simplification that allows our consciousness to navigate a profoundly intricate and multi-layered reality. To truly grasp the scale beyond the observable horizon, we must journey beyond the limits of ordinary thought, into realms where the very definition of existence is subject to re-examination. The human mind, a marvelous product of billions of years of cosmic evolution, is exquisitely adapted to perceive and interact with a specific slice of reality. Our senses are tuned to a narrow band of electromagnetic radiation. Our experience of time is linear, and our understanding of space is intrinsically three-dimensional. Yet, the theories we have explored, from cosmic inflation generating a vast, unobservable universe, to the string landscape positing countless realities with different fundamental laws, and even the holographic principle suggesting an emergent space-time, all demand that we stretch our cognitive frameworks far beyond these biological limitations. This is the profound power of physics, to allow us to conceptualize, to mathematically model, and to contemplate realities that lie entirely outside the scope of our direct experience. It is a testament to our intellectual curiosity, a quiet insistence on pushing the boundaries of what is knowable, even when the answers reside in realms we can never physically touch. In this grand intellectual pursuit, the very notion of what is fundamental undergoes a transformation. If space-time itself is emergent, arising from a deeper quantum reality, then the search for the universe's real size becomes a quest for the underlying code, the fundamental information, or the most elemental constituents from which all of existence, including space and time, ultimately springs. This echoes the ancient philosophical quest for a unified theory, a single elegant principle that can explain all phenomena. Modern physics, in its most ambitious forms, continues this quest, seeking a theory of everything that can reconcile the seemingly disparate realms of the very large, governed by general relativity, and the very small, governed by quantum mechanics. Such a theory, if ever fully realized, would not only describe the laws of our universe, but might also provide a coherent framework for understanding the entire cosmic landscape, the vast ensemble of potential realities. It would, in essence, reveal the true, ultimate size of all that is possible. The implications for our understanding of consciousness within such a boundless and potentially emergent reality are particularly profound. If our universe is one of many, and its laws are but one setting on a cosmic dial, then our awareness, our capacity for thought and wonder is a precious and perhaps rare phenomenon. It is the universe, in a fleeting yet meaningful moment, becoming aware of its own intricate design, its own boundless potential. Our individual consciousness, then, is not merely a localized event within a vast, indifferent cosmos. It is an intrinsic part of the universe's self-reflection, a delicate and intricate pattern woven into the very fabric of emergent reality. This perspective fosters a deep, calm sense of belonging, reminding us that we are not separate from the cosmic dance, but an active participant, a unique lens through which the universe experiences and contemplates itself. Embracing the profound unknown, the vastness beyond our observable horizon, the possibility of emergent realities, and the contingent nature of our own physical laws can be a deeply calming experience. It dissolves the illusion of absolute certainty, replacing it with a serene acceptance of mystery and an expansive appreciation for the universe's inexhaustible creativity. The true, real size of the universe lies not in a fixed number, but in its infinite capacity for surprise, its endless potential for new forms of existence, and its continuous invitation to intellectual exploration. It is a reminder that the quest for knowledge is not about reaching an end, but about embracing the journey, allowing our minds to expand with every new insight, every theoretical leap, every quiet moment of contemplation. This continuous unfolding, this eternal dance of discovery and wonder, connects us to something truly immense and profoundly beautiful. And so, as you drift deeper into tranquility, carry with you this sense of expansive wonder, world of peaceful, restorative. As our minds gently retreat from the intricate dance of emergent space-time and the profound implications of a potentially holographic cosmos, we arrive at a tranquil understanding. The real size of the universe transcends any simple measurement. It is not merely a number of light years, but a boundless tapestry of possibilities stretching infinitely in space, encompassing an untold number of realities with varying laws and unfolding across a dynamic, evolving expanse of time. Our observable horizon, while vast, is but a fleeting glimpse into this immeasurable whole, a luminous bubble within a grander, largely unseen ocean of existence. May these deep thoughts about the true, unfathomable size of the universe carry you into a world of tranquil sleep. Remember that the cosmos, in all its intricate majesty and silent grandeur, is an amazing, self-reflecting entity, and you, with your capacity for wonder and understanding, are an integral part of its enduring story. Fall asleep with this feeling of serenity, knowing that your consciousness and the boundless potential that lies just beyond the reach of our current perception. Good night.